Okay, so now we have just completed the decimal number system. Let's move on to how the binary number system works. Okay, so this is the second number system that we will be learning in computer science. Okay, the binary number system. Okay, so the binary number system, at the beginning, I told you guys over here when we spoke about inside the computer, I told you the binary number system has two states. Okay, the switches. Okay, in the computer, when it comes to storing data, it is stored in the form of electrical switches, no? And these switches can either be on or off. That is how we came to the conclusion that we call it binary, where it can be in two states. Okay, that's how we came to the word binary. Okay, now what your computer does is to understand how it's storing data for on. Okay, so if the switch is on, it represents it with a 1. Okay, and if the switch is off, it is represented with a 0. Okay, guys, where is it? Okay, so on is represented with the number 1 and off is represented with the number 0. Okay, so with that in mind, guys, okay, you can see the binary numbers are made up of binary digits 1 and 0. Okay, so when we talk about the binary number system, we are only referring to 2 digits, which is 1 and 0. That's it. Okay, so the computer, when it comes to storing data, deals only with 2 digits. When it comes to storing data in a form that the computer understands, it only uses two digits, which is 1 and 0. 1 meaning the electrical switch is on, and 0 meaning the electrical switch is off. Okay, right. Now, when you write binary numbers, okay, when you write binary numbers, for example, in computer science, when you write this number, okay, you must put the base. Okay, otherwise somebody might look at this and consider it as 10. Now, if you're writing 1 0, meaning you're referring to the binary number system, if you just put 1 0, somebody might assume that this is 10. So you must put the 2 over here. So the moment you put 2, the moment you put base 2, then the person who's reading, the examiner who's reading, whoever is reading your paper, whoever is reading your answer, immediately understands that you are referring to a binary number. So they will not read this as 10. They will read this as 1 0. Okay, so please make it a habit, make it a practice in computer science. Whenever you write numbers, you should mention the number system that you are referring to. So put the base. If it's a decimal number, you put a 10 base. If it's a binary number, you put a 2 base. Okay, make it clear, right? Okay, so every number in the binary number system, every number, think of a million, think of a billion, any number that you can think of in the binary number system can be represented by just ones and zeros. So it gets messy. Okay, when you represent a massive number just using ones and zeros, you can imagine how long the number is going to be. Okay, so get ready. Okay, now if we were to take an example of this binary number, okay, as you can see on the screen, I have given you an example of a binary number. Okay, let's take this binary number as an example and let us see how we can convert this into a number that we can understand. Meaning, how can we convert this binary number? Okay, let me write it over here. Binary number. We want to convert it into a form that we understand is what we call decimal. Exactly. We want to convert this into decimal format. Okay. From binary, we want to get this into a decimal format, a format that when, as soon as we look at the number, we can understand the value of that number. Okay. So the example that we have taken is this binary number. This is the binary number that we have taken as an example. Okay. So just like in decimal numbers, okay, if you do remember how we wrote decimal numbers, over here we have written the decimal number. You can see 110011, This number has been written from left to right. We have written it. Okay. Now what we do is we start from the right end. Okay. From the rightmost end we start. Okay. And what we do is we give it, if you remember, we give it what we call position values. Okay. We give it what we call position values. Okay. Position values. Okay, so we give it position values. Okay, so when we start from the right end, we start with 2 to the power of 0. Okay, so I do hope you remember why I took 2. Okay, the reason I have taken 2 is because we are using the binary number system, and in the binary number system, we have only 2 digits. In the decimal number system, we took 10 because the decimal number has 10 digits. Okay, over here, we are taking the number 2. because there are only 2 digits over here. So we start with 2 to the power of 0. As you can see, we have taken 2 to the power of 0, which is equal to 1. Okay, this is always the case. The next position is, the second position is 2 to the power of 1. Okay, the next position is 2 to the power of 1, which is equal to 2. Okay, the next position, if you look at the next position, it is 2 to the power of 2. Okay, the third position, the value of the third position is 2 to the power of 2, which is equal to 4. Okay, and then if you move on to the next, it's 2 to the power of 3. Okay, which is equal to 8. Okay, and then if you move on to the next position value, it is 2 to the power of 4. Okay, and it goes on. So 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. Okay, so I want you guys to again notice a pattern that's happening over here. If you look, guys, you can see 1 became 2. Basically, it doubled. Okay, times 2. 2 became 4. It doubled times 2. 4 became 8. It doubled times, okay, squared. Okay, it doubled. Okay, 8 became 16, it doubled. 16 became 32, it doubled. So I want you to notice the pattern with position values. So when it comes to position values, you will notice that each position value keeps getting doubled. Okay, now over here we have the values. Over here we have the values. Okay, and over here we have the values. Okay, so over here we have the values. Okay, so as you remember, just like how we did in decimal, okay, the values will be multiplied by the position values. Okay, so let's start from the right. Okay, let's start from the right, where 0 is going to be multiplied by 1. 1 is going to be multiplied by 2. 1 is going to be multiplied by 4. And you can see that has already been done at the bottom. You can see 0 times 1, 1 times 2, 1 times 4. Okay, and then if you move 1 times 8, okay, then 0 times 16. Okay, then we have 0 times 32. Okay, then we have 1 times 64. Then we have 1 times 128. You can see, so again, just like how we did in decimal, we took the value and multiplied it by the position value. Okay, and then what we did was, now you need to understand, if you look here, wherever there are zeros, okay, if you look at the zeros, for example, here we have 0, here we have 0, here we have 0. So 0 times anything is anyway 0. Okay, 0 multiplied by anything is anyway 0. So you can actually skip writing 0 times 1, 0 times 16. I have just put it over here to show you, but in your next few calculations, okay, if you see 0, you can simply omit it, because 0 times anything is 0. You can simply omit it without, wasting time writing 0 times 32 or 0 times 16. Okay, this is just a tip for you guys. Okay, because 0 times anything is 0. Okay, so if you look over here, 1 times 2 is 2. We have it. 1 times 4 is 4. 1 times 8 is 8. 16 times 0 is 0. Okay, so 0, 0. Then we have 64 and we have 128. Now, when you add up all these values, okay, when you add them all up, you would get the number 206. Okay, so this this binary number over here, this binary number, when you convert it into decimal, you would get 206. Okay, so can you see the difference in the two number formats? A binary number is written, the binary number 206 is written like this. Okay, and in decimal format, it's just 206, which is very much more easier for you to read. Okay, so just I want you to see the difference between the two. Okay, and I hope it makes sense on how we converted it. Okay, so we took a binary number and then we converted it into decimal format. Okay, right. If you move on to the next page, guys, if you move on to the next page, there are some questions that have been given to you. Okay, so let's attempt these questions. Okay, let's attempt this question. So for example, we have this number given to us. Let's take it. Okay, so let's take it, and let me start writing it over here in a bigger format. So 0, 0, 1, 1, 0, 0, 1, 1. Okay, so I have this binary number over here. I'm supposed to convert it into denary, or you can refer to it as decimal format. Okay, so once you have got your number, you start from the right end. You start from the right. Remember, you start with 2 to the power of 0. Okay, the position value at the right end will be 2 to the power of 0. Okay, so over here, sorry, over here, we have 2 to the power of 0, which is equal to 1. Okay, then here we have 2 to the power of 1, which is equal to 2. Okay. Then over here, we have 2 to the power of 2, which is equal to 4. Then over here, we have 2 to the power of 3, which is equal to 8. Okay. Then here we have 2 to the power of 4, which is equal to 16. Okay. Then 2 to the power of 5, which is equal to 32. As you notice, you can see it's doubling, 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 and going. Okay. So over here we have, I do not even need to write 2 to the power. I can simply write 64 because you can see it's doubling. Okay. So over here we have 64. Over here we have, let's double it. It's 128. Okay. Now, when it comes to the calculation, now you have to start multiplying the position. The position has to be multiplied by the position value. Okay, the value multiplied by the position value. Okay, the value multiplied by the position value. So like I told you guys, ignore the zeros. The zeros do not make any difference to your answer. So you can simply ignore them. Focus only on where the ones are. Okay, so we have a 1 here, we have a 1 here, we have a 1 here, we have a 1 here. Okay, so 1 times, what is the value over here? It's 32. So we have 32 plus 1 times 16. So we have 16 plus we have 2 plus we have 1. Okay, so if you were to add up all these values, so 32 plus 16 will be 32, 42, 48. Then plus 2 is 50, plus 1 is 51. So the answer would be 51. Okay, so the number 51 written in binary format would be this. Is it clear? The number 51, if you were to write it in binary, this is how you would write. Okay, so guys, I hope you would attempt the remaining questions. Okay, B, C, and D. Do attempt it. Okay, try and convert it into decimal format. Okay, give it your best shot. Okay, so this is how you convert a binary number. Okay, a number that's given in ones and zeros, a binary number. This is how you convert it into decimal format, a format that you can understand directly. Okay, I hope it makes sense. Okay, next. So for now, we have been dealing with binary to decimal now. So now I have shown you how to convert a binary number into decimal format. Okay. Next, we will be moving on to how do we do it vice versa? How do we convert from decimal to binary? How do we go from a decimal number to binary format? Okay. By the way, another word for decimal is denary. Okay, so you can say denary or you can say decimal. Okay, so next what we will be learning is how do we convert a decimal number into binary. Okay, that is what is over here, and there are two ways of doing it. Okay, there are two ways of converting a decimal number into binary format. Okay, right. So if we were to look at moving on to where we are going to be converting a decimal number into binary format. Okay, so there are two methods. I'll be showing you both methods. Let's look at method number 1. Okay, so method number 1, the example that has been given to us, if you look over here, they have given us the number 40. Okay, so this number 40, we are now supposed to convert it into a binary format. Okay, this number 40, which is right now in decimal or denary format, has to be converted into binary format. Okay, so what we do is method number 1 is what we do is we take the number 40, and then what we do is we look at this table, this position value table. Okay, if you look, this is what you call the position value table. Okay, because over here we have the position values. Okay, over here we have the position value, so we call this the position value table. Okay, right. So if you look at this table, okay, if you look at this table, you can see all the position values 1, 2, 4, 8, 16, 32, 64, 128, and it keeps going. We have stopped at 128. Okay, we have stopped at 128. Right, now what I want you to do is I want you to take this decimal number of 40. Okay, so we take this number 40. Okay, what we do is we take the number 40 and we look at this position value table. Okay, and we look what is the closest position value to the value 40. Okay, for the number 40, what is the closest position value? Okay, now remember, you cannot take a value that is higher than it. Okay, you cannot take a value that is higher than 40. For example, you cannot take 64. Okay, because 64 is higher than 40. You have to take a value that is lower and the closest to 40. So in that case, you would say yes, 32 is the number. So we put a 1 over there. Okay, because 32 is less than 40 and it is the closest to 40. Okay, so we come and put a 1. I think my 1 doesn't look good. Let me put it just a straight line. So we put a 1 at 32. Okay, because 32 is the closest to 40. Okay, now what I want you to do is I want you to subtract. Okay, you took 32 now, so you had the number 40. From that number 40 you have taken 32. Okay, so how much do you have remaining? 40 minus 32, the remaining you have is 8. Okay, the remaining you have is 8. Okay, 40 minus 32, you have 8. So now 8 is closest to which position value? 8 is closest to which position value? Yes, it is closest to 8 because that's the closest it gets. Okay, so 8 is closest to 8. Do we have anything else remaining? Because 8 minus 8 is equal to 0. There is no remainder. So what you do is for the blank boxes, all you do is you simply put 0, 0, 0, 0, 0, 0. That's all you do. Okay, so this is the first method or method number 1 that you can use to convert, okay, to convert a decimal number into binary format. So 40 in binary, okay, so 40 in binary is equal to, you can say 00 1 0 1 000. Okay, and you can put the base 2 so that the user knows this is a binary number. Okay, let's take another example. Okay, let's take another example. Let's take, have we got an example over here? We haven't got an example here, but I'm going to take an example from over here. Let's take the number. Let's take the number from here. Let's take the number. Let's take the number 75. Okay. Let's take the number 75. Okay. So this number 75, I want to convert it into a binary format. Okay. Using method number 1 where we do subtraction. Okay. So before we do it, shall we just get the position values in place first? So it will be easy for us. So if we get the position values, we start off with 1. Then that becomes 2. Let's put a line here. 2 becomes 4. 4 becomes 8. 8 becomes 16, 16 becomes 32, 32 becomes 64, and 64 becomes 128. Okay, so these are the position values. Okay, I hope you remember these are the position values: 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Okay, so instead of writing that, I have simply put the value itself. Okay, so now take 75. Okay, and see from these position values which one is the closest to 75. But remember, it has to be either equal to 75 or less than 75. It cannot be more than 75. Okay, so if you look at this, you will definitely tell me, you can easily tell me 64 is the closest to 75. Okay, so immediately what you do is you put a 1 at 64. Okay, now what you do is you take 75 and subtract it with 64. Okay, so if you subtract 75 with 64, you would get 11. Okay, 75 minus 64. Okay, you would get 11. Okay, now what I want you to do is I want you to take 11 and see in these position values which position value is the closest to 11. Okay, so you would tell me, yes, it is 8. Okay, I'm reminding you, you cannot take 16 because 16 is greater than 11. You cannot take a value that is greater than it. Okay, it has to be either equal or below. Okay, so we have 8. Let's put 1 at 8. Okay, so now what we have is 11 minus 8. Okay, so that is equal to 3. Okay, 11 minus 8 is equal to 3. So now take the number 3 and tell me which position value is the closest to 3. Yes, you cannot take 4 because 4 is greater. You have to take 2. Okay, so you put a 1 at 2. Okay, now what I want you to do is, so we have taken 2, so we have 3. 3 minus 2, we have 1. You can take the position value 1 over here. Okay, so let me ask you, what do you do for the empty spaces? Yes, for the empty spaces, you will be filling them with zeros. Okay, so you will be taking the empty spaces and you will be putting zeros over there. Okay, so the number 75, okay, the decimal number 75 is equal to 0 1 0 0 1 0 1 1 in binary format. Okay, so in binary, this is how we write 75. Okay, much longer. Okay, so I would recommend, guys, at least try and convert a few more numbers. Maybe you can try 136. Okay, and then maybe try a bigger number, 285. Okay, just try to convert a few more numbers using method number 1. Okay, where you use subtraction and you put it in its position values. Okay. Next, we will be moving on to method number 2. How can we convert a decimal number into binary using method number 2, a different method? Okay. So